Okay, this is number 41 from section 10.2, and we want you to graph. They want you to sketch the path of the particle, or sketch the path that the particle travels in exercise 37. Well, here's 37, and we have the x prime of t and y prime of t at t equals 0 with the initial value at 2, 6. So we want to find the position vector. If we can find the position vector, we'll be fine. So that's going to be x of t and y of t. Sorry about that. It's a little messy over here. This will be a t over here. Pardon me. X of t, y of t. So we want to find this position vector, and then we can put it in our calculator and graph it. But we don't have that. We've got the velocity vector. But we have an initial condition. All right. And this is the same thing. So we'll find the position vector, which will find the position vector, and that will give the position, actually the position without the vector, but it's the same thing. All right? So we know that this is x prime of t. If I put it from the Newton to the Leibniz notation, dx dt equals this. So we can work on the horizontal component. So separate the variables here. Take the antiderivative, and the antiderivative of this is going to be t cubed. T cubed over 3 times 3 is just t cubed. 2t squared over 2 is just t squared plus c. Now how do we find the c? Well, we got this initial position when t is 0. All right? X of 0 is 2. So x of 0 is 2, and I put 2 in for t. I'm sorry, 0 in for t. So I got 0 cubed, t was 0 squared equals plus c. So that ends up being 2 equals c. So there's my x component down over here. Sorry, I hope I didn't miss all that. Up, so it's real easy to just put it in. So we've got our x component. Now let's find our y component. So first of all, we know that my dy dt is going to be this. Separate the variables, take the antiderivative of both sides. Now I've got to adjust over here. Like we did earlier, we have to take the antiderivative of this. So this is the cosine of u. This is going to be pi t. So du will be pi dt. So I need the pi. So I have a pi here. So I divide by pi. And I did this all in one integral rather than separating like I did in 37. The antiderivative of 1 is t. And the antiderivative of the cosine of u is the sine of u. And I've already had it u dt, but I have this 1 over pi as an adjustment, plus c. So I take the antiderivative there. And then we know that y sub 0 is 6. So y sub 0 equals 6. And I put a 0 in every time I see a t. So that's 0. That's 0 plus c. The sine of 0 is 0, so that's just going to 0 out, so I just have c equals 6. So there's my horizontal component. And then we just put these in the calculator, and this is how I put them in. I put my mode into parametric. I forgot to mention this on 39, but I think you might have been okay, but no, we would have trouble 37. Probably had to make sure. Remember, we did some of the vector problems, especially the navigation problems were in degrees, so hopefully you remember to change your calculator from degrees back to radians, because you have to have radians for this parametric stuff. All right. So now we just graph it to find out what it's going to look like and trace it out. So this was your window. So let's see if you can see this here. There we go. And there's my y. And this was the t cubed minus t squared plus 2. That's there. And then I put the t plus, and I put a bunch of parentheses here just to be safe. And that's going to be my sine of pi t over pi plus 6. That's over here. And you can see where I put that in there. And I kind of experimented around with the window. Very similar to the window we used for our example, though. So we'll go to graph. This is my zoom. Or my window, and I went from 0 to 3, that's time, and I used the t step of 0.1. And then x from 0 to 23, scale 1, y from 5 to 10. And I indicated those on my little sketch over here. And this is what I traced off, and you can see when we graph it, that's what you get. So something like this. My window's up a little bit higher, so it goes a bit higher. This was going from 5 to 10, so this is 5, 6, 7, 8, 9, 10. So 6 to 7 is a vertical line that goes like that. So that's what they wanted you to do. You had to do a little bit of work to get it into, you know, the position vector by taking antiderivatives, and then you've got it. Okay? So make sure you think about these problems. A few problems with the right amount of due diligence will give you a good mastery of this material.